Somebody respond. Can you see my screen in full view mode?
Yes, we can see, sir.
It is
Okay,
visual.
Great. Thank you. So, whatever title I had given, multi-wavelength understanding of black hole galaxy coevolution, we will try to understand what do I mean by that kind of a scientific title. But at the same time, I will introduce you to the what was told that what is RAD at home, real astronomy discovery sitting at home anywhere in India. So how anybody, any science student of any university, how any person who has passed a science degree from any university, anybody can actually participate in the search of that kind of exotic black hole galaxy system and contribute to astronomy research. There is a new thing that has come up that is called citizen science research. I will introduce that. That is how, as I was introduced to, I'm a bridge between common man and the professional. So professionals are publishing difficult research papers that public do not understand. Not only I am helping the public to understand, but also I am calling the public to get involved in the discovery process. There is something new that has come up because of the power of the telescopes have increased so much, and internet is providing us through a laptop or a computer, not completing the master's degree or bachelor's degree, and even not getting paid for it, not getting trained in a full-fledged way like a PhD scholar. So this mode of research is citizen science that I will introduce to slowly, step by step. So let me just repeat something. I'm a UGC faculty at the UMGA Center for Excellence in Basic Sciences, which is inside the Mumbai University campus. I led this RAD HOME Astronomy collaboratory. It is not an institution. It is a virtual institution in some sense. It is not funded. There is no brick wall anywhere. It is a virtual institution. There is a collaboratory. Research participation only is happening on a specific topic. It is happening only. The black hole galaxy evolution. So it is mostly happens in the Facebook group. Then there are Google email communication for the secret communication, for not so public communication. Some of the science discoveries that I have made and came to the news that I have given here like an icon, exotic radio galaxy SPECA, and this is 3801, the NASA news that he was introducing me to. Then this is a icon or logo that you can call up what is RAD at home. RAD at home is an all India network training people how to be involved in GMRT telescopes, data interpretation and publishing paper. This icon is another way of saying what we have discovered recently. Galaxy, radio plasma that GMRT radio telescope can see. Logo of four of my institutions, UGC, which is giving me salary and recruited me for this job, University of Mumbai, DAE, and CBS logo. And of course, you know what this is, your own poster. So, coming back, it's a man-machine combination. Machine, which is GMRT radio telescope, Giant Metrewave Radio Telescope, led by late Professor Govind Swarup, FRS. This size of this radio dish antenna are actually 45 meters. From this end to that end, diameter is 45 meters. So you can imagine the huge antenna. But it is not just one huge antenna. There are 30 huge antennas like this, spread all over 25-kilometer area in a Y-shaped structure near Pune, in Narayangao, Khoda. So the power of this telescope is proportional to the collecting area, pi r square, into number of antenna it has, number of dish antennas it has. So this GMRT dish antenna's collecting power is 3 times larger than the American most productive radio telescope, very large array, VLA. Now we have such a world's best radio telescope in our country since 2000, and hardly our undergraduate physics students know about it. When I was doing PhD, when my senior goes for GMRT or telescopes observation, I would be left as the only student in the hostel. So that since those days in 2000, 2001, I had a feeling in my mind that power of the telescope is huge, best in the world, but where are the students who will use that telescope and make discoveries? Scientists are recruited there. They're busy in building the telescope. They're busy in making meaning out of it. But where are the students? By the time students realize, it should not be too late. So since those days, I was involved in a way that I wanted to through outreach program. When I finished my PhD and I was decided to return to India to start citizen science program, there I decided to involve the students as well. And that is how in 2013, I launched this collaboratory. I will train the students, and students can be anywhere in India. They will be working from home, how to interpret the best telescope GMRT's data, and can they contribute in some way to make a publication out of that data. So the thing that I have created, RAD at Home, is a man-machine combined network, human network, trained citizen scientists. Okay. So I am certainly not alone. There are many leading members of the collaboratory. The top line, you can see the PhD degree holder in astronomy. Bottom line, you can see the MSc PhD student like level. They are working like tool maker engineers. They not only have helped creating various training workshops, they also have created tools how to train the people, how the students will use those tools to report their discoveries. This is my core team, you can call it. Here I am showing a simulation. Simulation, or you can call it an animation also, it is not that serious simulation. The center, why I'm showing simulation in the beginning or animation in the beginning itself? Because this is the basic topic we are dealing with. We do not deal with constellation. We do not deal with space exploration. We do not deal with real cosmology. We do not deal with something else, moon, planet, certain ring, that kind of exoplanet, star formation. We do not deal with, because we have to be focused in one area so that quickly undergraduate student can learn some concept, look at the data, and make discoveries that can be published. So this is the basic, exactly the radio galaxy topic that we train everybody to understand and contribute. So that is why I'm showing you in in animation, so for you to quickly to become easy to understand, that there is a galaxy in the middle, yellow circle that you see. This is an elliptical galaxy in the middle, and relativistic magnetized plasma, electrons and positrons or protons, are coming out of this galaxy's central black hole accretion system at a relativistic speed, 10% speed of light. It comes out, goes far away from the galaxy itself, and it spreads into the cosmic intergalactic medium like a huge smoke plasma kind of smoke bubble. It comes out of the galaxy, spreads into the space far away from the galaxy. So when it coming out, it is slowly diffusing at the intergalactic medium. And at some point of time, the jet ejection process stops. When it stops, it just continues to diffuse in the space. When it diffuses, radiation continues, radio radiation continues, and it loses its energy. When it loses its energy, almost vanishes. Telescope cannot detect it. The pink color plasma that you see is visible to only radio telescopes. And the central galaxy is only visible to only optical galaxies. Radio galaxies, people see the galaxy is lobe, the plasma part is called lobe, and the galaxy optical people see. What does this outflow of the plasma does to the galaxy? That's a big question. The black hole in big galaxies are big. Black hole in small galaxies are less in their mass. They have a hand-in-hand relation. Big, massive galaxies have massive black hole, million to billion times mass of our sun, and less massive galaxies or small galaxies have small black hole. Like our Milky Way galaxy is a smaller spiral galaxy. It is a few million times mass of our sun, its mass. The black hole at the big galaxy center can be billion times mass of the sun. So the outflow that comes out, it affects the galaxy as well. So the bigger galaxies, which are elliptical galaxies, for several billions of years, they are not forming new stars. Whereas, like our Milky Way galaxy, spiral galaxy, they continue to form star always, new star forms. For example, like one new star form every day. every year in our Milky Way galaxy. And one supernova explosion will be happening in every 10 years. We may not be able to see it, but it happens. So this is that radio galaxy phenomena that we are focusing on. So the galaxy at the center, plasma outflow comes out, our GMRT radio telescope sees it. Okay. So as I was telling you, our team tried to understand this kind of plasma outflow from galaxies. And our student trained citizen scientists, they have discovered a unusual plasma ejecting galaxy. This is the picture that made news in 2022. Okay, what is this? There is a galaxy here, yellow color elliptical galaxy. There is another galaxy here, yellow colored here, another elliptical galaxy. Plasma from this galaxy, which is supposed to come out in both the directions, for some reason we do not understand now, because this is just a discovery image. We have to do much deeper understanding, a deeper study of that. Plasma comes out in the only one direction and seem to be trapped in between, or seem to be stopped by the other galaxy. Let me show you another simulation. This was a lot of news release happened. Royal Society gave a news release on this. TFR, NCRA, GMRT, they gave a news release. It came in Nature India, it came in Times of India. Various news reporters reported it. It got million Google hit, not Google hit, social media video views. Okay, lots of people have seen it, bringing pride to the nation, making RAD HOME well known. That's a different thing. But students come to know about that such a thing is possible, such a thing is there in India. Let me explain the same thing exactly again in the video. Two galaxies under their gravity, they are coming close to each other. They are trying to become one, or they are trying to merge. In the process of this merger, from one galaxy, a jet comes out. The relativistic plasma jet, where electrons, positons are moving at relativistic speed. So the synchrotron radiation from the relativistically moving electrons radiate in radio, so radio telescope can detect it. Radio telescope like our GMRT has detected that. So the plasma jet comes out in one direction and it hits the other galaxy and is forming kind of a mushroom bubble, and it kind of bouncing back. Such a case that the plasma hits another galaxy and bounces back has never seen before. Okay, that is the point, that why this was so famous. Is such a plasma returning back and forming a mushroom bubble is never seen before. What a jet shoot at another galaxy does is a wonderful laboratory to study. What happens when the jet shoots at another galaxy? The another galaxy's gas will be destroyed, the gas will be heated up, and future it cannot form new star. That is what is supposed to happen. A lot of simulation study this kind of thing. Okay, it is supposed to happen. I don't know why it is not going. Okay, let me start again. Just let me confirm. Can you hear me all right? Everything okay?
Yes, we can hear you.
Okay. So, the very concept of citizen science can be summarized in this picture. The relevance to current education system one can imagine here. You can see there is a small microscope and a small telescope. What is there? This is the facility that we have in our colleges and schools. These are educational tools that we can train them the meaning of telescope, meaning of a microscope, and show them such little bit details, like show them little sun rings of Jupiter, or show them some fungus or something, some kind of small experimental thing. And all the students are excited by big things. Say, for example, Higgs boson discovery, black hole, first image of black hole. Everywhere you will see this Medubara-like structure ring. How the student will be connecting their excitement and the availability of resources. They cannot connect at the current system unless we go to internet. So the educational facilities are only for education, telling them about big scientific aims. But they cannot be part of that big aim unless they participate in some kind of research project. That is what is bringing citizen science. Citizen science is not just in the astronomy, it can be in any field actually. The moment the data can be digitized, it can be given in the citizen science project mode. So what I mean, you may have a small telescope in your college to get introduced to astronomy, but be part of a network of citizen scientists where they are studying black holes or any kind of subject, say for example exoplanet discovery, any kind of project through a internet-based collaboration, for example here at home. So science education can be happening in a college and university, but doing research from the undergraduate level has already become a necessity, and through internet, through citizen science program, it must happen in the hostels and homes. Only then our undergraduate student will be competitive to the modern day competition, that is research plus education together. It is no longer the time that you complete your education and then go to research. Research has already gone into project mode of every student. The new education policy is also making it more involved in that process. The project component, the industrial training component there. So that is a bottom line of this image can carry forward this picture. We may be having a big scientific aim, but we have a small astronomy instrumentation facility or experimental facility. Through a citizen science project, internet-based project, we can have access to big telescope, big instruments data, and be part of the research from the undergraduate level. If a teacher wants to take a message from this talk, this is the message. So you can see a lot of logo of different institutions. All these institutions have formally, in a written way, has supported the RAD HOME citizen science by organizing a workshop, by giving a press release, by appreciating us, writing an article, various ways they have supported. So dozens of institutions have been supporting us. This is what I was telling, that Nature Index gave an article on us. Square kilometer array, the next big radio telescope that is happening, India is part of it, from 1,250 crore money has been allotted to this project for India participation. So in this project website also, the project proposal itself, they have discussed about RAD HOME, because it's a very innovative way of involving public, students especially, in the radio telescope programs. International Astronomical Union, I'm a member of that. In their article, their website, they promote people to join RAD HOME. I've given talks in their program. That's why there are a lot of international recognition. IAU also gave us fund to host a workshop during the International Astronomical Union Symposium on blazars in Kathmandu, Nepal. It was internationally funded with all of international participation. So this is that Nepal conference photograph. In the workshop we conducted there, first international workshop we conducted. We had been conducting all over India, but this was our first outside India. So all three of us actually were supported. We gave a talk there. 1 minute. So coming next, I conduct basically a one-day programs in going to different institutions where 100 to 200 students can gather there. I give them from morning to evening various lectures on how to make images of optical galaxies, radio galaxies together, and how to make meaning of those galaxy images that we will make. I will show you by the end of this lecture. I will show you how you can also make images of galaxies with GMRT data very easily with just few clicks. So once they get an exposure of what kind of objects GMRT telescope sees, then they will have certain amount of idea of whether to go to this field or not. From there, I will be selecting some of them and then take them to a bigger program, a longer program. For example, this is a group photograph of my program in ICTS, Bangalore, which is part of TFR, International Center for Theoretical Sciences. There, from morning to evening for 7 days, I will be training them how to make sense of those images, how to find new sources, and what is the meaning of these new sources, and how to prepare a report of their first investigation report of new sources. Those new sources, once they report, I can carry them forward to further investigation with the GMRT or other radio telescope. Or it is possible that it can simply start writing a paper on that. It is also possible. If the object is so good, you do not require so interesting, so unique, you do not require further data. So that is how the program continues, that we have 1-day program, we have Facebook program completely always 24/7 happening. We have weekend online live workshops happening. We have 1-day program happening. We have 7-day program happening. So in this hierarchy of training processes, various people get selected for intensive training for 7 days. And they work from home. Once they go back home from the training program, they continue to work. They continue to report their new find object or new discoveries, possible discoveries. So this is so interesting that during the square kilometer array week of the Vigyan Samagam, I went to Bangalore, I started in Bombay, I went to Calcutta, I went to Delhi. Everywhere I was called, and I gave exposure to what kind of discoveries the square kilometer array in future will make. Because smaller version of that is our GMRT. So what am I showing here? I'm showing here a plot of participation or comment over the year. So there are tens of 30, 40, 60 comments of images and text on the online weekend workshop that I conduct, looking like com. So the social media group itself, the Facebook group itself, I'm asking them to make galaxy images, post galaxy images, and discuss those galaxy images. They do not post their picnic photograph. They post galaxy images made with the GMRT telescope. So what we call this flying pyramid model, I may be the one. I have a core team, scientists which are collaborating with me, institutions which are hosting our programs, close to 200 people who are 1 week trained, close to 1,000 people who are 1-day trained or online trained, in a Facebook group of 4,700 members. This comb-like structure that you saw. So bringing large number of people to give an exposure of what the GMRT does is like an outreach. Giving them 1-day or 7-day training is like an education, which has a selection effect, selection process also. Involving their discoveries, keeping them as co-investigator, keeping them as co-author in the paper is absolute research. So the education, outreach, and research are combined in the system in a different way by online and by weekend activities hosted by different research institutes all over India at different times. It is happening 24/7, 365. Any student can participate in make a galaxy image, follow the documents, and post a galaxy image. Students are there to comment and discuss about that galaxy images. I come anytime, I also get time. Okay, this is a publication from that. Quickly, I will show you what data you can understand as what is happening in a galaxy. Multi-wavelength image, basically. So all these students, except the first few, the paper in 2014, the first conference paper that we had, by now we have already 17 papers in RAD HOME affiliation. This is what was in the PPR for the square kilometer array of India program. How to track galaxy evolution through low frequency radio continuum observation. using SCA in future, which is yet to come, and citizen science using multi-wavelength data. I will show you the multi-wavelength aspect of RAD at home. This year have already been discussed, mentioned, because of this innovative undergraduate involvement, education research combined system have been appreciated by CM, given award, ISOR Kolkata director, ISOR Berhampur director representative. They were appreciating this. I will show you a quick two animations again. This is the called Millennium Simulation. From redshift, very high redshift or close to the Big Bang, universe was almost filled with only hydrogen gas like thick, almost uniform, you can say. Slowly the contrast grew and structures formed, galaxies formed, groups of galaxies formed, bigger groups of galaxies formed, some clusters of galaxies formed, and bigger superclusters of galaxies formed. In that process from the outside, the matter has gone into the clusters, the cosmic microwave, cosmic wave-like structure. Wherever there is a junction, there is a cluster of galaxies. The galaxies are getting attracted, they are merging, they're going towards the cluster. So from outskirts, they're going towards the cluster. In this migration of galaxies from outskirts to the cluster center, the galaxies are changing their nature. They almost like the way we come from a village, we may be having a different dialect at home there, but by the time we reach the city, we become a city dweller, a metro city dweller, our language has changed, our nature has changed, our behavior has changed. The galaxies from outskirts, by the time they reach to the cluster, their nature has changed through merger and through various physical processes. We will try to understand what are the physical processes that is driving that kind of changes. That is what is galaxy evolution. How the universe's galaxies are changing with time, how the universe grew, and how it is in the structure formation process, the galaxies are changing their nature. Okay, so we'll go to the next animation. What happens when two galaxies merge? Let me show you the simulation again from the same Millennium simulation, the older one, 2005 paper, but the basic concept is still there. When the two galaxies are coming close to each other under gravity, their gas clouds are compressed. They are coming close to each other. If the galaxy gas clouds are compressed, they cross the gene spot, there is a limit. After that, new stars will form there. And those new stars blow up in supernova remnants, in supernova explosion. For example, now you can see the green color gas is blowing out from the center, from each of the galaxies. Because of the supernova, because of the stellar wind, it is blown. And when the two galaxies will finally merge, the same thing will happen again. That because of radiation from the black hole accretion process, because of supernova, the cold gas of the galaxy's remnant, the merger remnant, is blown apart. So in the process, the remnant galaxy of the is not in cold gas to continue forming new star. Radiation driven, radio jet driven, various processes are there to blow away this cold gas from the two spiral galaxies merging system. This is the hypothesis. This is the simulation. This is what everybody is supporting now. But nobody has found a smoking gun evidence or clear evidence of this. This is to prove that, say that this is a proven model. This is what we are focusing on. Can we find that kind of a proven system? How to prove that? To understand the galaxy's star formation process, to understand the black hole's outflow process. You see the outflow, gun, the smoke coming out of a gun, and the person dead. That is called smoking gun evidence. So we are looking for that kind of a smoking gun evidence, that can the outflow from a black hole accretion process that is coming out of a galaxy be figured out how old is that plasma, and then from the star formation understanding, can we say when the star formation process in the galaxy stopped? If these two time scale match, only then it can be called a smoking gun evidence. That evidence has not been found yet. By smoking gun evidence, The smoke that is left around after firing the bullet, after firing the jet, will be irregular, will be diffuse, will be faint. And citizen scientists are best to characterize and spot that kind of faint, fuzzy, diffuse emission from multi-wavelength data, multiple telescope data. Machine language cannot do better than human. So that is why I am employing a trained human to find that kind of concept. Okay, I will quickly show you how do we train our students to understand where is the star forming, where is the jet, where is the diffuse lobe, etc. So what we train our students is to understand the infrared, optical, UV images. A infrared telescope called WISE, Space Telescope by NASA. A ultraviolet telescope by again NASA called GALAX. A optical telescope old data called DSS, Digitized Sky Survey. To combine these three images with a web tool. Students will put the galaxy name. Three pictures in UV, optical, and IR will be combined together and shown to the student to understand what it is saying. Similarly, we have another way of combining images. We have TGSS, our GMRT data, in 150 megahertz, and NVSS, American VLA telescope data, in 20 centimeters. This will be put in red, this will be put in blue, optical picture will be in green. Similarly, radio, and UV optical IR, radio optical data combined way, I am giving the students to understand. That is how it becomes a multi-wavelength study. This is a simple tool. Anybody can go and use it. RADHomeIndia.org/RGB maker, RGB red, green, blue maker, RGB maker. You put your own name, put the galaxy's name or the coordinate. It will return you images. This kind of combined images. For example, this is a radio combined image. Red is from GMRT, blue is from American VLA, green is from the optical. So optical galaxy at the center is shooting this kind of plasma jet going up and going down. Similarly, I can show you another picture. So for example, you all know this is Pleiades or Kritika constellation. When you look at optical UV IR, optically you see the stars. 1, 2, 3, 4, 5 stars. But in infrared, you see the cold cloud, which is 100 Kelvin or 200 Kelvin, very frozen, like comet, frozen cloud, which is emitting in infrared. But none of these stars are emitting in radio. They do not emit at all in radio. This picture, the stars, optical light in green, and the radio light from American VLA and Indian GMRT, they are shown in red and blue. They're pink spots that you can see. You can notice here, none of the stars are giving radiation in the radio band. The radio band is seeing completely different thing. Not seeing the brightest star that our naked eye can even see. That is what is a surprise to most of the students when they see the brightest stars that they can see naked eye. The largest radio telescope GMRT, even VLA, cannot see it at all. It's a different process altogether. This is a non-thermal emission plasma that the black hole jet is creating and GMRT can see. And the stars are not creating that kind of non-thermal emission. The thermal bodies, 5,000, 6,000 degrees. Let me close this session with something else. So for example, this is an IOU picture, infrared, optical, UV picture. UV picture is shown here in blue, infrared picture is in red, and optical picture is in green. What do you see? You see that the galaxy's ultraviolet light is on the outskirts in the spiral arms. These are O and B type star, very hot, 10,000, 20,000 degree hot, and they can survive only for few million years, less than 10 million years. They will form quickly, they are heavy, they will burst in supernova. And this red region is the dust and pH, polycyclic aromatic hydrocarbon, very cold, 100 degree Kelvin, 200 Kelvin, that kind of frozen, sub-zero temperature cold dust. And the sun-like stars looking green here. There are several billions of years, 4.5 billion year is our sun. 4.5 billion year old, our sun. So few million year very young star, old star, cold dust, hot star, multiple components of the galaxies are seen in multiple different wavelengths. That is what is multi-wavelength meaning. So a galaxy showing ultraviolet light, it's meaning that the star is currently having star formation. That is why O and B type stars are seen in UV. If the galaxy is showing jet, for example, this galaxy, center of say in elliptical galaxy, ultraviolet, young stars, fine. Red looking thing, dust, fine. Green looking thing, very old, several billions of year old star, fine. But the radio emission is shown here in contour, the contour lines. It has no star, no gas, no dust. It is only relativistic plasma that the black hole accretion process is shooting out. So students actually learn these concepts. Anybody enters at home will learn this concept. How the radio wave is seen, how the UV picture is seen, what is the meaning. Can we find a smoking gun evidence of merger and jet coming out of the galaxy, turning the galaxy from star forming to no star forming. These are typical pictures of a optical galaxy and the radio plasma coming out from there. You put the galaxy name, the picture is coming out immediately within few seconds. A easy tool has been created for the students. These are all our own tool making students. People can understand various kind of radio galaxies. FR1 type, FR2 type, wide angle tail, all the plasma tails from these galaxies are seen pink. And the galaxy itself made up of stars, 100 billion stars, that will be seen green. Okay? As I was saying, all the radio galaxies were almost all hosted by elliptical galaxies. When I found one to be hosted in spiral or disk galaxy, it was an exotic finding. That to the three different episodes of jet has happened in that galaxy. That made a lot of news, and I became visible. And this was my primary driving force that I wanted to start a network of students who will make discoveries with the GMRT data. And from 2011, this is 2011 news. From the 2011, next year itself, I was almost sure. And by 2012, March 2012, by the NASA news time, I was already in India and ready to launch it. Okay, so without going much, I will say here that let the teachers help me involve students to learn what science GMRT does, and through the RAD HOME collaboratory, we will train those students to be part of a discovery paper. This will help their understanding of the concept. This will help prepare them for the next radio telescope SCA that is India is participating in. This will help them grow their CV properly. It will help them get selection in astronomy research programs in India and abroad. There are several dozens of my students through RAD HOME get recommended, and they are selected for PhD programs abroad. Close to 40 out of 200 that I have trained for 1 week long, they are doing PhD abroad. Okay, here I will say thank you very much, and let's help spread citizen science in India. That will be a new solution to our education, research, and outreach problems that we are facing for the big nation. Thank you very much.
Yeah. Thank you, sir. Yeah. So actually, sir, I must say here that it is not just in Goa, but everywhere in India. If you see the students, they have a lot of liking in the field of astronomy, trying to understand the major question which everyone is trying to know, that is about existence of universe. And for that, as you mentioned in your speech, there are various I can say telescopes, multi-wavelength telescopes we have in space and on land in India. But this is also at the same time true that uh, uh, information regarding this has not yet reached every student. And the sessions like this definitely will help our students to gain knowledge about this and take part in this. And absolutely true, black hole is something that it is everybody's passion. And you go and give a talk on any topic related to astronomy, students will ask you questions regarding black hole itself.
Yes.
So you have, I have visited GMRT at least 2-3 times, twice with students and then 2 times from Ayuka. I mean, and when you are showing the slides of how you do those, how you take the data, how you put your name and all those things, I really, I mean, I had a flashback. That was many years ago. I remember taking a student there who was doing his 12th standard, and we had a small group of astronomy organization here called Friends of Astronomy, which I used to manage long back, and we had taken them to GMRT. He was, I don't know, at that time he was so much inspired by that. After completing 12th, he went for engineering in Goa itself, but to do his project, he went to GMRT. So once you come to know that this kind of facilities are there, students really like to jump in. It's only matter that we have to reach them and tell them about it. And sir, thank you very much. You have once again inspired us with this talk, and there is a lot more to learn. And nowadays it's not just you do only X-ray astronomy or UV, and you have to look at all radio astronomy also, IR, UV, and then you get a much more clear picture. Uh, Thank you so much, sir, for this wonderful session.
Thank you very much.
Yes, before I move forward, let me ask Professor Ahluwalia to say something on this.
Yeah, thank you very much, Professor Hota. I think I really enjoyed your talk, and I think I really wrote a few things in the chat box also as I was listening to your talk. I think it was a great window of hope. And
thank you very much.
You have pointed out to what is going to happen in undergraduate education in terms of research projects, particularly with the coming of 4-year degree courses. So where are students going to find projects? Both teachers and students will have to hunt for the opportunities. And you have opened a gold mine for them through this talk. And I'm sure that we are going to share this talk with our community at great length, so that they come to know what we are actually doing and may inspire them to really do things. Because, when you were doing it, there were a few thoughts which were coming was that how do you mentor such a huge number? That's a mind-boggling situation. And please tell us something about that.
See, sir, the only magic solution that I had is the passionate students. Social media is a disturbance, but I had no other way but to go to social media. So I may not be having time to answer some students' question, but there is some student somewhere already feeling bored what to do then, but he knows the answer to that question. So feels very happy that I can answer that student's question. So that particular aspect, the students are always discussing. I may not be there to discuss. That is why I said it's 24/7, 365. That is active. I come only live Saturday 2 o'clock to 4 o'clock.
Oh, that's
but every time, every other time, is there. Whenever they make a galaxy image, they post. Whenever somebody has time, they answer it. So the expert that I have trained at the student level, they are managing the crowd.
That's nice.
So that means peer-to-peer interaction is the ultimate answer to this question of mentoring.
Yes.
So everybody tries to mentor each other, and I think that's a very happy situation.
That is the internet media group, basically. They record their video, how to do something, and share it among each other. I only come when these things becomes important, things become very seriously discussing. The senior members will tag me and inform me that there is something interesting happening. Sir, you can look at it now. There I come.
Yes, I think
Dr. Kulkarni.
we will definitely love to have you again and again here, sir.
Thank you.
Because we have about 10,000 members. Sometimes they are, in a what you call, they are sleeping partners. We want to really make them awake and see that what is happening on our platforms. And that is why, even though the number is small at the moment in terms of audience, but that doesn't mean that this message which you have given will not go far. It will go very far, I think. And hopefully we will keep on, bringing you and your students on this platform of NASNI, because that's very important.
Thank you. They will be happy to guide. That is what, when I had my first one-day workshop, it was in Institute of Astrophysics, and nicer faculties were also participating. And my students, after 7 days of training, they were feeling very proud that we were teaching how to do red, green, blue RGB image analysis to nicer faculties. That was so nice. So the students will be very happy to teach anybody interested in learning something, because that is the phase that they were excited that they know something.
There are two events we would like you to be to keep an eye on those two events, and we would very much like you to be part of that.
Thank you.
One is Dr. Reshma is going to host National Convention of IAPT in Goa, and we have a possibility of pre-conference workshops. We have started doing this in our conventions. Last year was the second year. This year we are going to really concentrate on real quality workshops. Second is, there is an international conference of physics education which is coming up in December 2025. It is basically again an international event which is coming to India after 20 years. And there also there is a provision for workshops of this kind. I think your presentation can be part of that, or you can have a small symposia around it, maybe a kind of a pre-conference workshop there. So we will keep you informed about it. IAPT is one of the co-hosts of that. So we are very hopeful that these efforts will yield some result, and the kind of exposure our students need, they will also get it. And I'm rather worried about that our teachers also need exposure, not just students, because they do not also have an exposure of this kind. So on behalf of IAPT, and on a personal behalf also, sir, I really thank you for the lecture which you have given to us here. And it is
Thank you very much. We can have
sorry to disturb you, sir.
Yeah, please.
Hello.
Dr. Kulkarni. Dr. Kulkarni is saying something.
Yes, Kulkarni speaking. First of all, let me say sorry, I joined about 20 minutes late, but I knew Dr. Ananda Hota for the last couple of years. We have interacted very little about 2-3 years ago when, I don't know, during the COVID period. And subsequently we lost contact. But nevertheless, what he said today is wonderful. We need to pull our undergraduate students into research trade. Once the undergraduate students get a taste of what research is, they will definitely flower and come out in a more aggressive way. This particular video, I'm going to show it in at least 4 to 5 colleges that I am aware about. Currently, I am more wondering about getting the youngsters into research. If our undergraduate students do not do some kind of research, not necessarily astrophysics, any other, they will have no future in the world of knowledge. They will have some jobs, all right, that is not the point. But to evolve further and, increase the knowledge content of the society, number one, and their own intellectual satisfaction, They have to be introduced to research as soon as possible. Once they join the college, they should be told that college higher education is more about research and less about courses. Courses should go on just like your Tanpura moves in a musical soiree. But again, Tanpura doesn't constitute everything of the musical soiree. In musical soiree, you need performances, and that is my research. Okay, the classes should go on so that the teachers get some work to do. But first of all, the undergraduate teachers should promote research as a fundamental thing. There is 50 to 60% of the time must go in research, and the remaining 30-40% of the time should go in teaching, and about 10 to 12% in administration. That is not happening because undergraduate teachers are not taking on to research, and consequently they are unable to guide the undergraduate students into research. Somehow this situation must change, and I welcome Dr. Ananda Hota's wonderful video. This particular, video recording, I'm going to show it to at least 4 to 5 colleges which are in my control, and hope that more and more students take up undergraduate research. In astronomy, in astrophysics, of course, it's very exciting. But in addition to that, any other thing. So first of all, they should be brought into research fold. Otherwise, I do not see how knowledge promotion and development will happen in India in the competitive world that we are living in. Thank you for time to comment.
Thank you. Let me give a comment on that. Okay. Delhi University BSc Physics course, wherever they have discussed about astronomy section, they have described RAD at Home and citizen science programs like Galaxy Zoo. So students, teacher need not teach that in the classroom, but students know that if I go and participate in those programs, I will be learning what is research like thing. It is simply required to be told to the student that where to go and participate for what kind of citizen science projects. People who are interested in whale, people who are interested in plant, people who are interested in birds, there are various citizen science projects that will help them grow research like attitude towards their learning. Thank you very much. Thank you very much for your appreciation. I of course will interact more.
Dr. Vandana will say.
Yes.
Yeah, good evening. Very, very enlightening and inspiring talk. And I hope that it will convey the message to the students. I just want to ask, recently in the research methodology paper, many databases of astronomy has been added. Those are ADS, that is NED, SIMBAD, and VISER-R. So in that, there is a provision to add the coordinates and other parameters of the galaxies, extragalactic ones beyond our galaxy, and get information about their spectra, about their photometry and other things. So are the data which is being generated by this, is that indexing is being done in those databases? Because their handshake can be done. Plethora, I think they have got million of objects which have got their parameters listed in these databases. NED is also by NASA and ADS is also by NASA. So is there any way in which these two because that also tells that how much is the redshift, whether it is negative, positive, whether the galaxies are moving towards or going away, and then from those parameters, this verification of the Hubble's law and all this, and same is the case with the SDSS, that is the Solan Sky Survey. So is it possible to know that is there any correlation between these two?
See, you certainly seem to have some exposure into the database analysis. That are the tools that is necessary for continuing research. And the students in RAD at Home, they get training to how to use NED, how to use ADS, how to use SIMBAD, etc. So I focus on finding new sources from new data like GMRT TGSS, new data, for example, LOFAR's images. So the TGSS or LOFAR new data catalog may be available in NED or SIMBAD, but until and unless that particular source's importance is discussed that object is not discovered. The data may be there. What is the size of the data? What is the size of the galaxy? What is the distance of the galaxy? Everything may have been measured by automated way, but that doesn't mean how unique is the galaxy has been realized by the data set. So that is what the students are trained to do. They see a picture, they see the multi-wavelength images, and they understand what is unique in it, what is unusual in it, what is importance of that thing. So that is the difference between giving a tool training for education and giving a training to do some kind of small amount of research.
And I must tell you that Red Hat is very much popular because out of when I see the CV of many students of mine also, from networking or through collaboration, they get to know about it and they are a part of many of these projects otherwise also. Like, I think there is a solid networking which is already there for this. Am I right? Can you comment on that?
Ma'am, where are you from?
I'm from New Delhi.
New
Delhi University.
Okay. So this Delhi, as I said, Delhi University, the course has already given. There are many students from Delhi University. I have done probably 5 workshops in the Nehru Planetarium. So Delhi University students are well exposed to what is RAD HOME doing.
That is what I am telling you, that there are, we have not hosted you anytime, but I think students know about you very much. And that is, it is good to know. And I think if there is a search in that particular database, because as NED, there is a correlation that that object has been verified or cross-checked by many other, say, sources also. So that way they can be, I think, inclusion in the database also, if something new comes up.
Yes, there are a few raised hands.
Aditya Karekar. Aditya Karekar, please.
Yes, sir. Hello, sir.
Hello.
It was a great lecture. So basically, I'm from Rajaram College. I work as a CHB there for Astronomy and Astrophysics department. So basically, to extend to that project, how can I be join you or your team for extending my work as well as work with your team correspondingly regarding this? Because the work and the motivation that I have in astronomy as a career, it aligns it well. So I want to extend my work in it a little bit.
So my first question is, are you teaching astronomy there?
Yes, sir. We have a short course there for the first year and second year BSc, as well as I give some BSc level research projects to the students as well.
Okay.
So
next question is, do you have a PhD in astronomy?
No, sir. I'm currently hunting for a PhD abroad. Okay. So I'm putting an application.
So you can write me an email, and we can think of arranging how your student can participate in the RAD HOME project and grow their project. There are currently 6 BSc, MSc students doing project with me. Formally, the college has to agree that they will be doing a project in RAD HOME. If that is yes, then they can do a project under me. I will be the co-guide. You will be the formal guide in the college.
Okay, sir.
Okay. You write me an email, hotaananda@gmail.com.
Okay, sir. Sure.
Okay. Thank you.
Sir? Hello, sir.
Yes, sir.
Sir, when we conduct star parties or sky gazing sessions, then sometime question comes like our galaxy and Andromeda galaxy will collide after some time, maybe million or billion years. So to confirm it, do we have this similar data from GMRT or other way where we can show it as really it will happen after some time? Can we have this kind of data from there also?
See, all kind of interesting news that you see in the website, all kind of research cannot be done through GMRT. As I showed, the stars are not seen to GMRT. Andromeda galaxy and our galaxy may be merging, that has to be modeled through the velocity field measurement of the stars in those galaxies. That is better done in optical astronomy, measuring the spectroscopy of each stars. And GMRT is not the best tool to do that. GMRT is more focused on understanding pulsars, understanding hydrogen gas emission line, absorption line, focusing more on plasma outflow from black holes, etc. So it is not GMRT that is necessary. It is other telescope spectroscopy study, optical telescope spectroscopy study, and simulation, theoretical simulation of the kinematics of those galaxies merging. That is going to predict what billions year time scale, where exactly, which way exactly they are going to merge.
Okay, sir. Thank you. Thank you.
Bharatji wants to say something. He's unmute, looks like.
Hello. Hello, Dr. Ananda Hota. Bharat Adur.
Hello, sir.
I have a small query for you.
Yes.
The data which you are acquiring from these radio telescopes,
Yes.
is there any summer vacation camp where people can actually, where students can actually see how you can get the data and how it is analyzed? Because that is something which is most essential even for amateurs who are interested in doing radio astronomy, is to how to get this data from the radio telescopes. This is my question for you, which I think you will be able to guide us better.
There are multiple answers. If a amateur astronomer want to download free data, that is archival data from GMRT, TGSS is freely available, all sky survey. Otherwise, a raw data if you want to download, you need to register in the Goa GMRT online archive. There you can download the raw data, but the next problem comes in that you need to analyze that raw data to get the images or get the spectrum. To do that, a summer student program is organized in NCRA every year. One can learn through that program if you get selected. If you do not get through a student mode, then you need to collaborate with somebody who will analyze it for you, whatever kind of data you have downloaded and want to understand it. Suppose, for example, you have downloaded data based on a global cluster somewhere. There are tens of pulsars maybe. So somebody you need to collaborate with who can analyze that raw data from the GMRT that you have downloaded. That way you can do your science with the GMRT data that you have downloaded, or it's freely available, whatever form it is. What I do is, after students' discovery, I follow them up, propose to the GMRT, and collect more data on that. For example, what we discover from GMRT is only 5 minutes of GMRT data in that part of the sky. But when I go and observe with GMRT again, it will be different frequency and 5 hours, not minutes, but 5 hour, more longer data, more deeper data I want to take, so that I can get a good publication. You can talk again.
Thank you.
Thank you.
Yeah. Any other questions from the audience? Fine. So if there are no more questions, let me thank you on behalf of NASNI for this wonderful session. And we are looking forward to have you in Goa University for our national convention with your team. And
thank you very much.
Thank you. And thank you, Hemant sir and Aluwalia sir.
Thank you, madam. Thank you, Hota sir, for sparing time for us. Thank you so much.
Thank you very much.
Professor Aluwalia and all other senior members, Dr. Kulkarni.
See you again sometime.
Thank you so much.
Yeah. Bye, everyone. Good night.
Bye. Good night.
Good night. Good night.